What's up, YouTube? It's MR2. We'll take a look at Mr. Angus discovery here about Energia scale and its perpetual motion holder. And if you're not familiar with it, go look into Energia scale perpetual motion holder. A guy named Matt Emery was one of the first I've seen that actually replicated the perpetual motion holder with the battery and the end cap. At any rate, it's the same principle here. We're passing a magnetic field between the two end pieces of the horseshoe rather than putting a cap on the end of it and using it as a stationary magnet. Now, what first we really need to pay attention to look at is how we've been producing and using electricity for the past 100 years or so. And this is a modern day induction motor, and you can see here they have the horseshoe iron piece, which is called a stator, with a magnetic wheel. This is actually a motor and one wind in a coil of wire, just one wire wound and round to both ends. And when you induce electricity into the coil, it causes the magnetic current to flow through the iron stator, creating magnetism, which is repel and attracts the magnets on the wheel, causing it to turn. This creates a lot of resistance and uses a lot more energy than you put into it, or than you get out of it, excuse me. And that is what these two, in fact, this is one of those coils right there, identical to that, and I wound one here just to keep the wheel kind of even, and we'll use those, and I'll show you the difference between that and this. And what we have to pay attention to, the key factor, is how much electricity does that go into the machine to begin with. We have a 12-volt motor here that's just powered by a 12-volt battery, and I got an amp meter hooked to it to tell us the amperage use that it's using when it's in motion. And of course, the less amperage that goes to that motor means the less electricity that it's using, which makes the wheel actually turn faster. So I got a little RPM gauge here, and we'll be able to use it too to tell how fast the motor's turning. And you can see here what I got on the output side is just two little DC motors with some little propellers on there, so you can see that they run, and they're called a DC or bridge rectifiers. It converts AC to DC, and there's one on the breadboard. There's no big. It's 4 diodes turned in proper direction to convert the AC into DC direct current. All AC generators are AC internally. The AC generator has to be converted to DC right off the bat. So, and the reason for that is because you have a magnet here that has a north side and a south side, and in order to create a pulse of electricity, you have to isolate that. The next time has to be a south and a north. You have to flop that over, and each time one of those go by that, it creates an opposite field. Now, in that coil, it creates what's known as the lens effect, which the more you apply, the stronger the resistance is between the iron core in the center and the magnet passing by it, which causes the wheel to slow down. If you've ever seen a generator run or anything like that, plug electricity in, you can plug in and see that it puts a drag on the engine, causes it to run harder. When you use this type of system, it does the absolute opposite effect, which completely breaks Lenz's law altogether. And so here we go. We'll try it, show you how it works. I want you to see how sensitive that this wheel is with these two coils. Let me just turn it by hand. You can see just by turning that just a little bit, the motors take off. You hook them to that little coil down there, they won't even move by hand. At any rate, we'll take everything off of it. There won't be anything on it. We'll turn it on. And we'll take a look at the amps and the pulls and the RPM that it's spinning. And let's get it evened out here. Let's take a look. RPM gauge. We'll hold it in that place. 435 RPM, 34, somewhere in there. 435, somewhere in there. and we're at 2, where you see it, 2.09, 2.1 amps roughly, 2.1 amps. Now if we come over here and hook something to it, we'll go with the conventional type system that we normally use, and we'll see what happens. You can see here, this is just the DC motor with bridge up top. I'll put this on here. Of course, it'll provide current, make that motor run. We'll put one on each coil. Electricity hardly get it going. It's turning. You see these two little motors, one's hooked to this coil, and this motor here is hooked to this coil right over here. Now we're drawing 2.2 amps, almost a tenth of an amp more. And of course the wheel speed, check that. Down as we below 400. Right at 400, so we lost 5 minutes speed on the wheel, which means that that motor, input motor, is working harder to produce the electric current through the conventional type coil. Okay, so now let's unhook these. We'll immediately notice the engine go up, start to go faster. We'll go back to normal speed. Gets back to normal, see, it gets back to 2.09, 110. Wheel speed back up to 230, 430 RPM roughly, 125, just a little bit slower. Amperages 2.09. This is a dramatic difference. We're going to hook this to the other two coils. PMH coil, one on each one. Just did. You immediately hear the motor start speeding up. Yeah, both of them running. So the wheel's speeding up quite considerable. If you look at our amperage draw now, and we're below the amperage that we started with nothing hooked to it at all. 2/10 of an amp lower, or at least well 1/10, a little over a tenth of an amp lower than this. No, 2/10. We started at 2.09. So it's quite a bit of a drop on the input of that motor. It's not working nearly as hard as it was just with nothing hooked to it. And we'll take a look at the RPM, and it don't lie. Here it is. 490 RPM, which is way considerably higher than it was even with nothing on it. So yes, there's definitely an effect here that the more of these we put on here, the greater that effect is going to show up. It shows up right here with 2 of them. It will certainly show up with 4, and so on. It also proves that the way we've been getting electricity with the conventional type one-winded coil is certainly more needs to be looked into. A friend of mine, Matt Emery, he suggests that what is happening here is, turn this off, you have a north and a south hitting the core at the same time because it's connected. And you have a north magnetic field traveling through this winding at the right-hand rule, while the south magnetic field is traveling through that winding at the right-hand rule. Because they're traveling in opposite directions, the coils are wound in opposite directions. And this proves that positive and negative travel simultaneously, back and forth at the same time. And not only do they do that, they create an over-unity effect. So I hope that helps people understand what's going on with this, because we need a lot of people to look into it, and it's certainly, I'm going to be looking into it a whole lot more. Certainly got my curiosity here. So having said that, thank you, Mr. Angus Wangus. You're awesome. Awesome, brother. Awesome. Peace and love. Big heads up.